Okay, chapter 8 is on proportional reasoning, and the first section is on comparing and interpreting rates. So you did a little bit with rates in junior high, and now we're going to introduce unit rates, which is basically a rate in which the numerical value of the second term is 1. So for example, if you're traveling at 50 kilometers per hour or texting 30 words per minute. Unit rates can help us figure out the cost of multiple units, basically taking your unit rate and multiplying it by what the quantity of what you want. For example, if chicken breast costs $2.99 a pound and you want to buy 10 pounds, you just multiply the $2.99 by 10. Unit rates are also helpful when you're trying to compare things that aren't given in the same units, so it's hard to decide what's the better buy or whatever until you compare them both to the same unit. So in this case here, first example, we have, for example, the month of May, Jessica sent 4,216 text messages, and during a 1 week period, Patrick sent 1,008. Who has the higher text rate per day? So, the first one, Jessica, she sent 4,216 messages in the month of May. So May, if you remember your little rhyme from years ago, 30 days have September, April, June, and November. All the rest have 31, and then something about February. But May has 31 days. So there's 31 days in May. And that will give you, Jessica, a unit rate of 4,216 divided by 31. Gives you a rate of 136 messages per day. Whereas Patrick sent 1,008 messages over 1 week period, so that would be 7 days. So 1,008 divided by 7 gives him a rate of 144 messages per day. So now it's a little bit easier to see that Patrick actually has the higher text rate per day. All right, so the second example says Natasha can buy a 12-kilogram turkey from her local butcher for $42.89. The local supermarket has turkeys advertised in its weekly flyer for $1.49 a pound. There are about 2.2 pounds in 1 kilogram. Each store has a lower price. So if you look at the supermarket, obviously that's already written in a unit rate of $1.49 per pound. So the supermarket has a rate of $1.49 a pound. So if we want to compare the butcher's price, we would have to, or it would be easier to compare the prices if we had the butcher's price per pound as well. So the first thing we need to do though is change the 12 kilograms to pounds. So 12 kilograms, every kilogram has 2.2 pounds, approximately 2.2 pounds, so 12 times 2.2, I think that's 26.4. So that's 26.4 pounds. So therefore the price at the butcher would be $42.89 divided by 26.4 pounds. Which would be $42.89 divided by, 26.4 will give you $1.1624. So that would be $1.62 per pound. So this one here will be cheaper. All right, example 3, when making a decision about buying a vehicle, fuel efficiency is often an important factor. Mario started his trip with a full tank of gas. Each time he stopped to fill up the tank, he recorded the distance he had driven and the amount of gas he purchased. So on which leg of Mario's trip was his fuel efficiency the best? So we'll talk about the first leg of his trip will be after the first fill up. So the information there with in the first row of your table. So you would look at fuel efficiency would be the number of kilometers per litre, more than likely. So 645 kilometers in 48 litres. So that would be 645 divided by 48 would give you 13.4. It's 0.4375, which rounds off to 0.4 kilometers per litre. And then the second leg of the trip would be, first of all, we have to find out how many kilometers. So it was 1,037 since he started the trip. So he had already driven 645. So the number of kilometers between fill-ups would have been 1037. Take off the 645, which is 392 kilometers. So therefore, the fuel efficiency for the second leg would have been 392 kilometers in using 32.1 litres of gasoline, which would give you a unit rate of 12.2 kilometers per litre. So in terms of fuel efficiency, he was getting more kilometers per litre on the first trip. This is the better fuel efficiency. Because he got more kilometers per litre. Okay, so we can often use information provided in graphs to help determine rates, and the slopes of the lines are significant when you're looking at the rate of change from a graph. So the slope is the rate of your rate of change. So usually when you're talking about slope, you're talking about rise over run. So whatever's on the y-axis would be your units for the rise, and whatever's on the x-axis would be your units for the run of your slope. So in this case, we've got population. It's hard to read this, but it's the population in the last 50 years of Newfoundland and Labrador, and the population count in, I think it's in the thousands. I'm not sure. But anyway, it says you don't actually have to calculate any particular slopes here. They're just asking you about what do the positive and negative slope represent. So when you're talking about a positive slope, in this kind of a graph, you're looking at an increase in population over time. So it's an increase in population in this case over time, which is in this case years. What does a negative slope represent? A decrease in the population over time, in years. And what does the slope of a horizontal line represent? Well, that would mean that the population didn't change as time went on. So the population didn't change. So no growth or decline. Just stayed the same. What does the steepness of the slope represent? The steepness tells you how fast the population is growing or decreasing. The steeper the slope, the faster the rate. All right, example 4 says to determine the rates for each segment shown in the graph below and convert each rate to kilometers per hour. So I'm just going to call this 1 2, 3, 4. So if I look at 1, we want to look at the slope. The rate would be the slope for that line segment. So the rate would be your rise over your run. And you can either calculate that using, counting the rise over the run, or you can use points. And again, remember, if you want to, slope is y2 minus y1 over x2 minus x1. You can use that formula as well if you want to get the coordinates of 2 points, x1, y1, and x2, y2. You can just use that formula. But I'm just going to count. It's easy to count the rise and the run in this graph. So if we look at this point here at the beginning of segment 1 and the end of segment 1, there is a rise of 2 over a run of 30. So 2 kilometers over 30 minutes. So we want to change that to kilometers per hour. So I'm going to multiply that by 30 minutes would be, if I want to get rid of the minutes and hours, so I want 1 hour, and I want to change the minutes to hours, so these minutes will cancel out, and then I'd be left with 2 times 60 in the top, or 120 kilometers over 30 hours, which reduces to 4 kilometers per hour. And the second one, the rate, would be your rise over your run, which in this case would be no rise over a run of 10 minutes, because you're going from here to here, which is just a 10-minute run. And this would be kilometers per minute, which is going to be the same. If it's 0, it's 0. So that would be 0 kilometers per hour as well. And 3, the rate at section 3, your rise and your run, from the beginning of segment 3 to the end of segment 3, you have a rise of from 2 up to 5. So that's 3 kilometers in. From here to here would be 40 up to 60, so that's 20 minutes. Which is, or we're going to multiply that, sorry, I want to change that to kilometers per hour, so that would be, I want hours in the bottom now, so I got to get rid of the minutes in the top, and the connection between hours and minutes is 1 hour has 60 minutes. So then I multiply the top, and the minutes are going to cancel, sorry. So it's going to give me 180 kilometers in the top over 20 hours in the bottom, which is going to give me 9 kilometers per hour. And then the last one, the rate, rise over run, would be, your rise here would be from 5 down to 0, so that'd be 5 kilometers. And you're going down, so that's negative, over positive run of 60 to 65 from here to here, so that would be 5 minutes. Again, if I want to change it to kilometers per hour, I need to get rid of the minutes, replace them with hours, and there's 60 minutes in 1 hour, so the minutes cancel now, and I'm left with negative 300 kilometers over 1 hour, 5 hours, I'm sorry, which is negative 60 kilometers per hour. So that rate is negative because you are, your distance is decreasing, or you're on your way back home. All right, so can you interpret each part of the section of the graph? So the first section would be, if you're looking at a scenario of on the way to the store, the first section would be on the way to the store. And 4 kilometers per hour is not very much, so you're probably walking. And the second piece says your rate is not changing, or So it's a 0 kilometers per hour, so you're not moving. So that means you're at the store. And then the next part is a little bit confusing if you're talking about a trip to the store, because it looks like they went, instead of going back home, they actually continued on, went for a little walk, started to go for a walk. It might be actually a jog, because they're going a little bit faster at 9 kilometers per hour, but then suddenly realized, so that's not spelled right. Oh, no, I can't erase it. Okay, suddenly realized needed to go back home. And got a ride with someone. Because they went back fairly quickly, and the speed went up to 60 kilometers per hour. So probably got to drive. Maybe they saw a friend or something and got to drive home. Okay, example 5 gives you, it says the following table represents the average cost per litre of regular gasoline in Newfoundland and Labrador for the first 6 months of 2011. And now I think this table is wrong, because I can't see the gas price being $121.2 per litre, so I think that's supposed to be cents, not dollars. Anyway, we'll just go with what we have here. So we have on the x-axis we'd label our months: January, February, March, April, May, and June, so they would be months. And on the y-axis we'd have our cost per volume, which would be, I think it should be cents per litre. So I'm going to make that executive decision there. So then we just plot the points. For example, for January it was 121.2. So if we look at the scale, this little mark here just means piece of the section of the graph is left off. So they don't need any of the values less than 120. Instead of starting at 0 and going up to 120, they left that little, so those two little strokes there just mean that piece of the graph is left out. Portion of the graph is left off. So a portion of the graph is omitted. All right, so if you look at the scale, it's starting at 120, but it seems to be going up 122, 24, 26, 28 to 130. So this would be 121.2 would be somewhere between 120 and that first line. 123.6 would be between the second and third one there. And then 131.4 would be here. And then 139.2 would be about here. And then 133.1 would be about here. And then the last one, 131.9, would be about here again. So if we connect them, just so you can see the growth, it says using a graph determine between which months the cost per litre of gas decreased the least amount. So the only months that showed a decrease were from April to May and May to June. And the one that showed that it decreased by the least amount would be from May to June, because it had a less steep slope. And the D slope would be less steep slope and decreasing. Decreasing meaning a negative slope. Okay, so these are some practice questions now that you can try, and they're on Schoology if you want to look at the answers. I guess I can go through them quickly. It says, oil is leaking out of the bottom of a storage container at a constant rate. After 1 day, the oil level is 60 inches, and after 4 days, the oil level is 48 inches. So on the grid plot, the order appears to represent the given information. So looking at that, I would probably think that the level of oil would probably be your y-axis, oil level, in inches. And then on the bottom would be your days. So this would be 1, 2, 3, 4. Actually, I'm going to go back and do that every 2 because 1, we only need to go up to 4 and don't want it too squished. So 4 and 5, and then the oil level has to go up at least as high as 60. So I would probably label every second 10, 20, 30, 40, 50, 60. So it says after the first day the oil level is 60, and after 4 days oil level is 48. So that would be about right here. So it's obviously decreasing from 60 down to 48. Hard to draw that nicely. So it says calculate the slope of the line segment joining the ordered pairs. So we've got 1 with 60, and we've got 4 with 48. So therefore the slope would be 48 minus 60 over 4 minus 1, which is negative 12 over 3, which is negative 4. And the top part of our slope, the rise part of our slope, is inches. And the bottom part of our slope is in days. So it's negative 4 inches per day means it's losing 4 inches per day. So it says the slope represents a rate of change, a change in oil level divided by change in time. What units are used to represent this rate of change? I actually kind of answered that up there. So technically slope would be just negative 4. So this would be inches per day. I kind of went ahead of myself there. Yeah, because technically slope would only be negative 4. Complete the following. The oil level is changing. That should be supposed to be the word increasing. And you have to circle which one. Is it increasing or decreasing? In this case, it's decreasing at a rate of 4 inches per day. And the last example there says the graph shown represents the amount of fuel in a gas tank as a function of the distance traveled by a car traveling at a constant speed. Calculate the slope of the line. So the slope would equal 20 minus 60, y2 minus y1, over x2, 240, minus 30. So that would give you negative 40 over 210. And that would give you negative 4 over 21. Or in this case, because it's liters and kilometers, you might want to change that to a decimal. So it kind of makes more sense. So this would be approximately negative 0.19. And then again, that's technically just the slope, so we write it as a rate. It would be representing the amount of fuel in the tank, which is again decreasing because it's going down, and we got a negative slope at a rate of 0.19 liters per kilometer. All right, so there's some questions there for you to try now in your textbook that are related to this.